Okay, today's learning target video is starting unit number 2. So if you could go ahead and get out your video notes for unit 2, and we're going to start with learning target 1. Obviously, you'll notice that learning target 1 is called generate a recursive formula that models a context, and then there are focus problems given to you. I think last unit we might not have done the best job of telling you that those focus problems never have to be done as homework, and they're always posted on your note sheets. So just kind of ignore those for now. We'll be doing those in class when we do this investigation and look at this as a group. As always, if you have any questions, fill out the question form online and we will address them at the beginning of class. So let's get started with some vocabulary. A recursive sequence, and there's those focus problems I was talking about. A recursive sequence is an ordered list of numbers defined by a starting value and with a rule. It's based on a pattern. So what this looks like is it's basically just a sequence of numbers that follow a rule. And we're going to have a start value. Okay, so we're going to write these like start, and then we'll have a number where we start. And then the next value will equal the previous plus something, minus something, divided by something, or times something. Okay, there will be a rule that we follow with each sequence. Okay, so let's say we have the sequence 12, 14, 16, 18. Okay, and obviously here we're going up by 2's. So our rule would be to add 2 both times. But each of these numbers in the sequence is called a term. And what's interesting about these sequences, is that this is called the 0th term. Okay, so that's the 0 term. This would be our first term. This would be our second term, third term, so on and so forth. So here, our start would be 12. And then the next is going to equal the previous, and you can either write previous or now. Actually, you know what? We're going to stick with previous, and I like to abbreviate. People in my classroom know that. Previous plus 2. Okay, so that would be our recursive sequence there. So let's look at a few examples. Here we're asked to write a recursive routine for the next 3 terms in the sequence. So first of all, we need to write this routine. So I'm noticing here that we start at 7. And then what's happening each time here as we go from 7 to 12, 12 to 17, 17 to 22. I'm noticing that we are adding 5 each time. So our next is going to equal the previous plus 5. Okay, and if we were to add 5 then, we would have 27, and then add 5 again, and we would have 32, and then add 5 again, and we would have 37 to find the next 3 numbers. Okay, so moving on over here, we're going to write our recursive routine. We start here at 5, and then our pattern here, we're going down by 4 each time, I'm noticing. And so next is going to equal previous minus 4. Okay, and this is an additive sequence, and so this also could be written as next equals previous plus a negative 4. Same thing. Adding is just always, subtracting is just adding the opposite. So if we subtract 4, add a negative 4 to negative 7, we're going to get to negative 11, and then we'll be at negative 15, and then we'll be at negative 19. So that would be our sequence there. Example B has a table that shows the heights above and below ground at different floor levels in a 25-story building. We're asked to write a recursive routine that provides a sequence of heights, -4, 9, 22, 35, so on until 217, that correspond to the building's floor numbers, 0, which would probably be our basement, 0, 1, 2, and then use this routine to find the missing values in the table. So first we're asked to write a recursive routine. Never forget that. Sometimes in these wordy word problems we forget that they might have asked us a question at the beginning. I'm going to say that we start at -4. That's our 0th term. Okay. And then our next, let's look at our pattern here. Our next seems to be adding 13 each time as I'm looking at these numbers. 13 feet are added each floor. Okay, so our next is the previous plus 13. Okay, so as we go from 3 to 4, it's pretty easy to see that we're just going to add 13 and get to 48. Okay, so as we count by ones, we're just adding 13, adding 13. Notice now, though, we jump and we go from 4 to 10. So we add 6 floors on here. So our task is to find out how much do we add from 40 to 48 to get to the 10th floor. Where I'm going to think out loud here for a second. I'm thinking that each floor has 13 feet and we have 6 floors. So if I multiply that, I should get what I'm going to need for 6 floors. Okay, so if I multiply 13 times 6, that's 78. Okay, now is this floor 78 feet up? No, because we were already 48 feet up with our 4th floor. So I'm going to add that 48 to my 4th floor there, and that'll get me to 126. So at the 10th floor, I'm 126 feet up. Okay. So moving on, now we know the difference in heights. We know that there is a 91-foot difference here between 126 and 217. So we need to know what floor we're on when we're 217 feet above the ground level. So I have 91. And if I divide that, I'm thinking by 6 because I know, oh, not by 6. I don't have 6 floors anymore. Divide that by 13 because I know that there's 13 feet in each of these floors that we're moving up. That gives me 7. That doesn't mean I'm on the 7th floor. That means I need to add 7 floors to this 10, which will put me on the 17th floor. Okay? So that one we're kind of going backwards. Here, when we had the floor number, we multiplied by 13. Here, when we have the feet change, we divide by 13. Okay? And then here, from 17 to 25, we are going up 8 floors. And so I need to figure out how many feet we're going up here. So if I go over here and I'm going to take our 8 floors times 13, that'll get me 104. That's times there. 104. Let me make that cleaner in case you guys are taking notes. Okay, so I'm going to go up 104 feet. That's not to say that my height is 104, but 104 plus the 217 that I'm already at, that's going to give me a height of 321 feet. All right. So sometimes plugging in these recursive sequences, you have to use different ratios to get there. Okay, but really, each one floor we're adding 13, and we will use these recursive sequences to kind of transition into some other learning in this investigation. As you look down through the learning targets, I'm sure you can guess what that learning will be. For class, I'd like you to consider the following scenario. Ben's school is 3/4 of a mile, or 3,960 feet, away from his house. At 3 o'clock, Ben walks straight home at 330 feet per minute. you're asked to write a recursive routine that represents Ben's distance from his house each minute after 3 o'clock. Okay? So, you are tasked with that. Bring that to class. As long as any questions you may have, remember to put those in the form online, and we will see you then.